Okay, so we're going to talk about periodic trends, which we can think about what's happening in the periodic table and look at what happens as we go across or down the table. And all of the trends really are based on what's known as Coulombic attraction, which is pretty simply what you think about when you think about electrostatic attraction. I have a positive and a negative, and they are attracted to each other. Okay, and if I have two positives, they will be repelled. Okay, and so what Coulomb's law says is that the force of attraction is equal to some constant times this Q1, Q2 over D squared. Now that seems kind of complicated, but it's really not. So it's just, if we think about an atom, we can think about Q1 as the number of protons, or the number of positive charge. And we can think of Q2 as the number of negative charges. So the more protons and electrons, the greater this denominator is and the greater the force of attraction. And the other interesting thing here is that the denominator is the distance squared. Okay, so what that would mean, let me just erase some of this. Would mean that if I have a proton here and electron here, that attraction is much stronger than if the proton were here and the electron were there. So the closer together the charges, the stronger the attraction. Okay, and we can explain most of the trends we're going to talk about based on Coulombic attractions. And I suggest not memorizing the trends, but being able to rationalize your way through them based on Coulombic attractions. Okay, so the first trend we're going to talk about is atomic radius. And you can think about atomic radius basically as the size of the atom. So it's typically would be measured, and there's not a lot of agreement on this, on exactly how to measure it, because of course the electrons, the edge of where the electrons are is not very specific, right? Because they, according to Heisenberg, they can be anywhere, right? But we can identify a pretty good area where the electrons are, the electron cloud ends, and where the nucleus is, and it's the distance between the nucleus and the edge of the atom. If you actually were to bond two atoms, it would be the half of the distance between them. Okay, so it's just a reflection of the size of the atoms, and we can talk about the relative sizes of the atoms. So if we think about this, now I know in your packet it says trends going across a period first, but I want to start by talking about trends down a group because I think they're much more intuitive. So as you go from, let's say, lithium to sodium to potassium, each time you do that, you are adding an additional shell. And it's kind of like the skin of an onion, right? As I add another layer of onion, I just get bigger. So as you go down a group, you are adding additional shells, so the atomic radius will increase. Because as you add more shells, those electrons are further away. Alright, so that part's pretty intuitive. The trend across a period is a little bit less intuitive until you start to think about it. So as I go across, let's say I go from sodium to magnesium to aluminum all the way through, what is happening is at the same time that I add an electron on the outside, I'm also adding another proton. So as I go, this is nitrogen, as I go from nitrogen to oxygen, I'm adding another plus. And I go to fluorine, I add one more plus, and if I go to neon, I add another plus. And as you do that, you're increasing Q1 and Q2, the positive charge and the negative charge. And I think about this kind of like a bungee cord. Every time I add another electron, I'm adding another proton, and there's attraction here. And I add another bungee cord and another bungee cord, and as I add more bungee cord, what it does is it serves to pull in that outer shell. So what you see happening with atomic radius is as you go across and you add protons and electrons at the same time, it pulls the outer electrons in, and the atomic radius goes down. Okay? So overall, the trends look like this. So as I go across, the atoms get small because I'm adding protons and electrons, adding more bungee cords, pulling this closer to the nucleus, making them smaller. When I go down a group, I'm adding another shell, and as I add another shell, it's like another layer of the onion. It's making the atom bigger. Okay, so we're going to stop right there.